Hello everyone to a new video series. Today I'm talking about Advent of Code. It's this new website that, it's not new, it's been there since 2015, but I kind of found out about it quite recently. And in this website, basically that livens up in the month of December, every single day until the day of Christmas, a new coding puzzle. I mean, not exactly coding, it's just a puzzle is released to the entire world. And it's made by this amazing guy called Eric Wastel. Really sorry if I mispronounced his name, but basically he runs the website and he releases a new puzzle every single day at midnight UTC -5. So, I mean, that's since I'm here in Germany, in Berlin, it's around 6 a.m. for me. And quite lately, I've been waking up at 6 a.m. in the morning, way before my usual waking up time, and just to solve this puzzle as soon as possible. There's like a huge leaderboard as well, where people um, compete against each other, and we have private leaderboards as well, where you can create a community amongst yourself or within work and then share that leaderboard. So that's what I'm going to be doing here, basically trying to go through each one of these puzzles and solving them. So let's actually before we begin, I'd like to talk about my tech stack. So the question itself doesn't really tell you to code on the website. It's just a regular question, math question, or could be just a regular puzzle. All you need is the answer, which is usually a numeric input or could also be string. And you would just need to submit that answer. So your task is basically to solve this problem using any programming language that you know. And I'm most comfortable with JavaScript and also quite recently TypeScript. So for this particular series, I'll be doing all of the puzzles in TypeScript. Not only is it in TypeScript, but I'll also be adding tests written using Jest. So Jest, if you're not sure, if you've not heard about it, is basically a testing library. It's usually used with things like React and all of that, but we can extend it we can make use of it with plain old vanilla TypeScript as well. What we're going to be doing is basically making sure we get the expected values using test-driven development instead of just checking whether it you know works. So this sort of teaches you more about how to build like a resilient project as well, and also have fun coding puzzles. So let's actually begin. I'm going to be starting off with this problem, day 1, Advent of Code 2021, and it's called Sonar Sweep. So before I start any problem, I have this project directory here. I will update the link to the GitHub repository in the description below. Basically, I noted down a number of events, but basically at the start of the day, I create a new directory here. So I'm going to create a new directory called day 1. And in this, I'm going to create 3 files. I have a template here, which, since most of the puzzles are quite similar, there's a part 1 and a part 2. Just kept a template to make it much faster. So I'm going to create a new file here called index.ts and add the template files here and also test. Let's copy over test. So here we have, the input that we need and all of that. Yeah, sounds good. Now, we also need one more file, which is basically the input. So let me create a new file called input.txt and paste it right here. Now let's actually run the test. We should change this to, it's just a personal preference to change the name of the test, but no. So I'm going to run this test right now, and you can see the output is as follows. Basically it's passed. And This is because the input is trying, I mean, we're just checking if the input is empty, and input is indeed empty because it returns .length. Now we can actually begin coding. So the name of the puzzle is Sonar Sweep. Let me read it out. Um, so you're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights because, of course, it is. And it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. So that's basically the gist of Advent of Code. You get the first part 1 of the puzzle unlocked immediately, and then you can start solving it. And once you've solved it, you get 1 star, and then you also get access to the second part of the puzzle, which also grants you 1 star. In total, 2 stars. So this is where the question actually begins. So let's start. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. Okay. On a small screen, the sonar sweep report your puzzle input, and puzzle input usually is right here to begin with. And this puzzle input is generated randomly or using some sort of key specific to your user. So the input that I get would not be the same input that you get. So if you were to see the results as well, don't be alarmed if I get a different result than what you do. So it's just how it is. Unless you use the same input, of course. So this is the input. Let's keep that open for now. So on a small screen, the Sonar sweep report your puzzle input appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report. So this is like a sample input. This report indicates that scanning outward from the submarine, the Sonar sweep found depths of 199, 200, 208, 210, and so on. All right. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried away into a deeper water by an ocean current or a fish or something. Okay. To do this, count the number of times a depth measurement increase happens from the previous measurement. There is no measurement before the first measurement. Okay. In the example above, the changes are as follows. So 1 to 99, there is no previous measurement to compare. 200, there is an increase of 1. Okay. 208, there is definitely an increase. 210, there's an increase. 200, there it has decreased, so it's just not counted, and so on. So there are about 7 increased steps right here, and that's what we need to return. In this example, there are 7 measurements that are larger than the previous measurement. How many measurements are larger than the previous measurement? So what we need to do is basically take this input. It's a series of numbers like this, and process it with our, the algorithm, or I wouldn't call it maybe an algorithm. It's just like some code, just to not sound daunting. It's not really that difficult. We're just going to write some code to process what we can actually do with our own pen and paper. So just to make it easier, so let's actually begin. Again, I'd like to say right off the bat that my solutions are nowhere going to be, big O of, yeah, it's not going to be the, most optimal solution is what I'm trying to say. I am going to focus more on writing cleaner code and more understandable code, and also just making sure I'm having fun. So that's about it. It's not a competition for me at least. So let's begin. Let me first add the input that we have. So let's copy over the input, select everything and copy it to input.txt. And I'm also going to maybe have another file called sample. Okay, file called sample.txt. And this will have like the sample input that is in there in the question, just so that we can work on a smaller input and share test to see if it works on a smaller one and then move on to the bigger input. So for this, I would need to write a test, and let's call it part1 sample. And I would need to import the file as well. So let me import it right here, input sample, read file sample.txt. So in the repository, I have a bunch of helper functions, which under the helpers folder, again, related to arrays, hashing files and stuff like that. And so inside files, I have, just a one-liner to get the file from the file system. So that's what the read file function is doing. So we've got sample and we can just pass part1 of sample and expect the result. So looking at the question, we expect that the result should be 7. So let's write that at the expected, part1 should equal 7. So now if I were to run this test, I can, I'm using WebStorm right now, so I can just run an individual test like this. And it should most definitely fail because, that's like a different problem altogether. Looks like I need to, TypeScript is telling me that I need to return a number. So, initially it was returning input.length. I'll just keep it for now and run the test again. So looks like, yeah, we expected 7, but we received 39. And 39 is basically the length, how many characters this particular string text file has. So it has no real meaning. One second thought, I don't know what I was thinking. I might actually just move from WebStorm to using VS Code again. I'm more comfortable here. So yeah, back to basics. Let's go back to where we were. I think it was events 2021 day 1 and index, and yeah, that's where we want to be. So let me run the test like so. When using the terminal, I'm going to use VS Code's terminal right here. When using the terminal, I can just do npm t or npm test and just run the pattern right here. So I'm going to call it 2021/day1, and it'll run the test, specifically that test. So yeah, that's what we need. Let's go back to our code and start actually coding the question. So we have these lines. We would need to separate them by lines first, separate them by a new line character first. So let's start doing that. Just so that TypeScript will allow us to continue, I'm going to keep returning input.length so it doesn't throw an error because it needs a number. And just going to console log input for now and check if everything's working. So npm test day 1. And yeah, looks like I have the input. So before I actually begin with the actual input, maybe I want to just run, just the sample and not the actual input. So I'm going to begin with just part1 sample. Now let me run the test again, and we should see just one test running with that console log. Awesome. That gives us a good starting point. Now let's separate by lines. So I'm going to say const input lines equals input.split of /n. So we've split by lines here, and this should have like a string array, but we also need all of them as numbers. To convert all of them to numbers, I can just map and call number. This would convert this into a number array. So this is one of the neat little things that VS Code's IntelliSense or something, or TypeScript provides you. an insight into what the type is before you even, compile your code. Now we need a counter variable. So just gonna call it counter for now. And next, we might need to just set that to 0 starting. And let's implement a simple for loop. So let I equal 0, I less than, I think it's input lines dot length. And yeah, just I plus plus. So we've got this, and now what we need to do is basically check whether, no, we're going to be starting from the first number though, so not really counting the first one. The 0th index, we're always going to be starting from first. So it doesn't make sense to actually keep I as 0. We can just set I equals 1 and go until the length. And now inside this, we just need to check if the previous number is lesser than the new number or the current number. So I can do that by checking if input lines, or instead of calling it input lines, I think it makes sense to call it measurements, because there are measurements. So measurements dot, or not the dot, of I minus 1. So that'll get me the previous element. Is measurements of I minus 1 lesser than measurements of I? So if it is, I would just increment my counter. So counter plus plus. And yeah, that's sort of it. Now I can just return a counter instead of input.length. Let's return that and check if our test is working. So npm run test. And yeah, it passed. So let's take, it worked for the sample input. Let's go back to test and see if our input works and actual input works as well. So initially it's set to 2 equal to 0. And this is how you basically write tests. You make sure they fail first, and then, find out if they're actually working, and then, right. But then, this is not a testing tutorial. All right. So yeah, we expected 0, but we received 1451, and 1451 should be our answer. So let me just enter it and check if it works. And it does. That's the right answer. You are 1 gold star closer to finding the slay keys. Awesome. We can continue to part 2 in just a second. I'm just going to update my test to equal 1451 and run the test again to ensure that, yeah, it works. All tests have passed. Now let's actually head to continue part 2. So that'll be right here, part 2, starting now. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of 3 measurement sliding windows. I believe that's like the key term right there, sliding windows. Again, considering the above example. So 199 is A, 200 is A, 208 is A, and then you have, no, it's not really clear, even to me, looking at this input. Maybe we can read further. Start by comparing the first and second 3 measurement windows. The measurements in the first windows are marked as A, 199, 200, 208. All right, so this is the first window. Their sum is 199 plus 200 plus 208 is 607. The second window is marked B, 200, 208, and 210, which is this section right here. All right. So basically they overlap, but they move by 1. Its sum is 618. The sum of measurements in the second window is larger than the sum of the first, so the first comparison is increased. Your goal now is to count the number of times the sum of measurements in the sliding window increases from the previous sum. So compare A with B, then B with C, and C with D, and so on. Stop when there aren't enough measurements left to create a new 3 measurement sum. All right. So in the above example, the sum of each 3 measurement window is as follows. So, A, B, C, D, E, F, G, H, and we have 1, 2, 3, 4, 5, 5 measurements that are increased. So the answer for the sample input is 5. Let's actually update that in our test for part 2. I'm going to create a new test called sample and update this to sample, and the answer is 5. All right, awesome. So let's actually take a look at how we're going to be solving this. We need to be creating a sliding window, and the apple doesn't fall too far from the tree. And what I mean is, the code that you've written for part 1 is most likely and mostly the code that you would also use in part 2. Most of the things would repeat. It's just the main logic that would change. So I think we can do something similar as what we've done already, just because we've understood the first first part really well. So we're going to be needing measurements anyway, so I'm just going to return that and also have a counter. So let counter equal 0 and also return counter. So nothing changes there. We still need to return all this. So it turned into a const automatically because of my editor, but we can change that later. So we still need to loop through these elements, but not in the same way. So let's take a look. We basically need to take a look at the input and see them as batches. We need to start from the first to the third, and then take a look at this, and then this, and so on. Well, not exactly that. We'll be taking a look at the first 3, and then leaving the first one, the next 3. So it's sort of like that. So how would we go about doing that? Let's start I equals 3 instead of 1 or 0. So we always start at the 0, 1, 2, and third one. So we start here always. This is because at the first comparison we have both windows, A and B. So we continue collect all of this information. So we're going to be starting from I equals 3, which is starting from the 4th element. And I less than, I think this stays the same, measurements.length, and I plus plus. Now here we're gonna be getting the first 2 windows. I think that's like the first important step. So again, not the best solution. I'm just gonna create a solution that we all understand. All right. So I'm gonna be creating 2 const variables, first window and second window. And the first window is going to contain measurements of I minus 3. So basically in the first section, this is going to have, this is 3. I'm going to go 3 spaces back and get the first element. So it'll have 199. So this is going to have I minus 3, I minus 2, and I minus 1. So when I'm at the 4th position, it's going to go back 3 steps, 2 steps, and first 1 step back and get all the numbers here. So this would consist of window A as expected. It'll have window A. And the second window is going to have measurements of I minus 2 and I minus 1 and also I. So basically when I'm starting at the 4th position, I would require the element from 2 steps back, which is this one, 1 step back, which is this one, and also the current index 210, this one, which consists of the window B, or in our case, the second window. So we've got the first window and second window. Awesome. Now we just need to basically find the sum of this value. So we can do sums of arrays pretty easily. I believe there is a helper function I've written just to calculate the sum, and let me run through the function to understand this, because we're going to be using this. We're using reduce here, and let me actually write that down here. So we have first window, which is basically an array of numbers. I'm going to reduce, And reduce is basically used when, I mean, so a quick rundown, we have map. Um, so array dot, okay, I can just do this. Array of map, array of filter, and array dot reduce. I mean, these are like the three major ones, and you also have a few others called every, sum, and all of that. But these are the three major ones that you would often use. They come from JavaScript's ES6 syntax. Yeah. So map is basically whenever you want to, I mean, how do I explain it? You have an array of n items. You want to return, and it all depends on what you want to return. You want to return another array of the same number of items. So n equals n. This is where you would use a map. So let's assume I have 1, 2, 3, and I would want to return the squares of all the numbers. I want 1, 4, and 6, 3, 9. I'm bad at math. So basically, this is one example where you would use map, wherever the input length of the array is equal to the output length of the array. That's the best place. Filter is sort of opposite. If you want just certain numbers, if n does not equal m, n is where you would use n filter. So if I were to do something like, I want only even numbers, let me actually add a 4 in there. So here I would return 2 and 4, and here basically it's not m but m. So if so I'm just going to call it input.length is equal to output.length. This is where you would use map. If you would use filter, you would use it whenever input.length is not equal to output.length. So just a simple way to remember where to use which function. Now reduce is the most fun one of all. Whenever you have like an array, let's assume the same array that we have. Just gonna reduce it to 3. So it's of size n, but you always want to return just one number or one object or just one thing of everything. So if I were to do something like this, I would want to return the sum of all the numbers like we're about to do now. So 3, 4, 5, 6, we want to return 6. This is of size 1. So this is usually whenever you want to reduce the array into just one number or one object or something like that. So this is the best use case whenever you want to find the sum of an array. So when input.length becomes 1, this is where you would use reduce. I'm just going to keep this commented out for now and continue. I would want to find the sum of the first window. Let's do first window to reduce, and reduce takes basically two parameters, or two parameters. The first one is a function, and I'm just gonna write the function right here, and the second one is an initial value. And the initial value here for sums at least is always 0 because you want to start off from 0. Inside the function, you want to enter the ACC, which is actually stands for accumulator, but you can call it anything you want. And also the number, or you can also call it item or anything you want. You can also call it value, which makes sense here. So here where we should be returning the sum of both ACC and value. And what this would do is whatever gets returned here becomes the new value. So ACC contains 0 in the initial stage. So ACC is a number. It will contain 0 in the first iteration, and then value will contain the first item inside the first window array. In the second iteration, the value which is returned is updated to the reduce function, and you have ACC as the first value which we have here. Let's assume it's like 1 in this case, and value will have 2. So it'll run that function again. 1 plus 2 is 3. So the next time the function is run, ACC will have the value 3 and value will also have the value 3 because it's in the third iteration of it. So 3 plus 3, you'll get 6. So that's basically how reduce works. And this is what it returns. Reduce now returns a number. We need to capture that number. So I'm just going to call it first window sum. And this is how it looks. So instead of, we're going to be reusing this function a lot, not just in this problem, but in many other problems. And that's why I made it into a separate function, helper function like this. And again, you can see that the syntax is pretty much the same. You have an accumulator and the item. We're returning the accumulator and item sum together with a default value of 0. So I can just call sum of first window and it would return the same thing. Let's do the same thing for second window sum and pass second window as the parameter right here. Now all we need to do is still inside the for loop, we're doing this. We need to check if first window sum is greater. Is it greater? It's lesser. Yeah. So we need to check if first window sum is lesser than second window sum. And if so, we're gonna increase counter. Now it's gonna error out on me because counter is a const and we need to convert it into a let. So we've done that and we should be done. Let's actually run the test now. Let me just run the sample, not the entire thing. So yeah, looks like part 2 sample also worked. It's equal to 5. Now we're going to be testing for the actual input. Again, it's equal to 0. So we wouldn't expect it to pass. The actual answer is 1395. So let's actually check if the answer is 1395. And lo and behold, it is. So let me just update the answer right here and expect that the test should all pass. Awesome. So yeah, that's basically it for the first problem. We've got 2 stars, and yeah, maybe in the next video if there is one, we'll take a look at the second problem. Dive. Thank you guys for watching, and girls for watching the first video of this series, and do let me know in the comments if there's anything I can do better, if it's the sound of my voice or if it's the size of yeah, I think I would increase the size of the editor. I should have done that initially, sorry about that, but yeah, I will make sure I do that next time. Thank you folks. See you next time.